Yeah.
So I think I have. And what we'll do is we'll go ahead and review Lecture 2 from the PowerPoints, and then I'll review a couple of examples.
Cool.
So again, we're going to review today the different purposes for keeping inventory. We want to understand the different costs. And again, I think I mentioned on Wednesday, those are great multiple choice questions, right? And understanding what those costs are. We want to describe what the economic order quantity is, how to calculate it, and we're going to do something that's also called looking at if you were offered a price discount to purchase in volume, how would you make the decision on whether or not you would actually do that, okay? So, again, kind of a refresher from where we're at on Wednesday, right? We said that we're going to talk about single period, which is what we talked about Wednesday. Today we're going to talk about fixed order quantity, meaning that when my inventory gets to a certain level, that's going to trigger me to reorder, right? And then on on the following Monday, we're going to talk about fixed time period, which says I just know that every Monday I'm going to place an order, right? So those are kind of the three focuses of Chapter 11. And we've already done the single period or news vendor model. She says, I'm not sure what happened there.
It looks like the program froze. Wow. New PowerPoint.
Okay.
I hate it when that happens.
Trying to learn.
I do too. So, but I don't think it'll take just a second to get back where we were. All right. So again, these are those three inventory models: single period or news vendor model, used when we're making a one-time purchase of an item. Okay. Fixed order quantity model, used when we want to maintain an item in stock, and when we restock, a certain number of units must be ordered. And fixed time period, we're going to do it on intervals of time. Okay. Again, review the inventory systems comparison. Single period inventory, one-time purchase. You're trying to balance the cost of the inventory overstock versus an inventory understock, right? That's what we worked on Wednesday. Today we're going to work on the fixed order quantity models, which we call our event triggered, meaning when we get to a certain point of inventory, that event is what triggers us to then place another order. And we're going to talk today about identifying both the reorder point and what the economic order quantity is, okay, and why it's called the economic order quantity, okay? And when we talk about economic order quantity, we'll review these different costs because they're incorporated. The shortage costs are not, but the holding costs or carrying costs, right? It says if I have inventory in my warehouse, it costs me something, whether it's just the interest that I have invested in that or if it's insurance costs, right? There's a cost associated with holding that inventory. There are setup costs or ordering costs, and they're one or the other. So setup costs say it's something that you're producing in-house, but you're producing it for yourself. And every time that you change, you have to go back to set up to produce that particular product, right? There's a cost associated with the downtime from stopping production, resetting things to be for the right part and moving forward, okay? So that's setup costs. Ordering costs, on the other hand, are saying that if you're ordering from a third-party vendor, every time you order, right, you've got this cost associated with the time that it takes for a scheduler to figure it out, right? And there's some, again, some specific costs, but setup and ordering costs are one and the same in our equation, right? But it's a setup cost if it's in-house, and it's an ordering cost if you're purchasing from a third party, okay? And then, so in our fixed order quantity model, we start out with some basic assumptions, and then we'll work on how, okay, well, what if these aren't true, right? That we'll work on those towards the end of the lecture. But you're going to say that the demand for the the demand for the product is constant and uniform. And I'm going to grab slides here. And so we're going to say that our demand is constant and uniform, right? And that our lead time is constant, our price per unit is constant, our inventory holding cost is based on average inventory, ordinary setup costs are constant, and all demands for the product will be satisfied. Well, we have something in operations management called the sawtooth diagram. I know that's wildly exciting to you, right? But it's a pretty standard thing. And basically what happens is, in the sawtooth diagram, you're making kind of this drawing of the perfect world. And that's what we're starting out with today, is the perfect world. And on the y-axis is how much inventory you have on hand. And on the x-axis is time. Okay, so in the perfect world, right, I start out, I place my order, and we're just going to assume our order quantity is Q. So I place my order of Q and it arrives, and I'm working at a constant pace. My demand is entirely predictable, and I continue to use Q until I get down to 0. And magically, when I'm at 0, right, I have another order that arrives. So in the perfect world, we can time everything just right. So I get my new order in, I use consistently, right? And then as soon as I get to 0, my order of Q comes in, right? And that's what we call the sawtooth diagram. Okay? Now, the reality of it is, if I were to tell you that along this timeline, right, that I'm using 10 minutes a day, right, and my lead time is 2 days, where along Q am I going to have to reorder?
Right there.
Right here?
2 days, I guess. I don't have ink.
Yeah, so 2 days back, right? And at 20 units, because I'm using 10 units a day, right? So I can calculate my reorder point in this perfect world by saying that it is my average daily demand times my lead time, right? So again, in the perfect world, this is this formula for our reorder point, right? And we're going to order our quantity for Q, okay? All right, so again, this is just showing you that same sawtooth diagram. Okay, always order Q units when inventory reaches that reorder point, and inventory arrives after the lead time, and inventory is raised to the maximum level Q. So again, we're in this perfect world. Inventory is consumed at a constant rate with a new order placed when the reorder point is reached once again, right? So it's just kind of a repetitive arrangement. Okay, now we're going to look at what we call the total annual cost. Okay, they say TC. I like to say TAC because it helps with total annual cost. Okay, and your total annual cost consists of, if you remember, we talked about that we have ordering costs and that we have holding costs. Okay, and your total cost then consists of what's it cost me to buy the product, right? So it's my annual demand times my cost per unit, right? Plus, what's it cost me to order the product, okay? And so basically it's telling you what are your setup costs. So let's say it costs me $10 every time I order. So if S is equal to 10, right? It costs me $10 every time I order. And I told you that my annual demand was 1,200, right? And I was going to order in a quantity of 12, right? So annual demand is 1,200, and I'm going to order in a quantity of 12, right? That's going to leave me with, I'm going to have to order how many times? Say it again?
You lost me.
Okay, so if my annual demand is 1,200 units, and every time I order, I'm going to order 120 units, how many times a year am I going to order?
10.
10. Yep. So I'm going to order 10 times, right? Is that making sense?
Sure.
So then every time, if you need to identify how many times a year you need to order, you take your annual demand and divide it by the quantity that you're going to order. That's how many times a year you're going to order. If you're interested in your annual order, you're going to take that 10, then times your setup costs. And then what I just said, say our setup costs are 10. So it's going to be 10 times 10 is 100, right? Okay. So DC represents total product cost. D divided by Q times S represents your total order cost. You're going to need to know that for your homework. Okay? And Q divided by 2 represents your average inventory. Right? If I always get in Q and I use it at an even rate, my average inventory is going to be half of Q. Okay? Because half the time I'm going to have more than that, half the time I'm going to have less than that. Okay? And I multiply that times my holding costs. And your holding costs sometimes are calculated by taking, you might be given an interest rate times the actual cost of the product. So H can also be equal to I sub C, or I times C. Okay? All right. I told you earlier this week we talked about total cost, right? And when we talk about total cost, again, we're going to look at cost, and we're going to look at quantity order. So when I look at cost and quantity order, right, I think we said if I have 0 on hand, my holding costs are 0, right? But for every time I have a unit in inventory, my holding costs are going to increase. And that's a linear relationship. Okay, so this is my holding costs. So as I order, right, if I only order 1 unit at a time, I'm going to have 0 holding costs because I'm going to use it as soon as I get it. Okay? But the larger my queue gets, right, the longer I'm going to hold that inventory. So think of that same example. If our demand was 1,200 units and I ordered 1 unit at a time, I would never have any holding costs. But if I ordered all 1,200, right, all the way out here, my holding costs are going to be high in comparison because I'm going to hold that. I'm going to hold 1,199, right, for some portion of the year. Right? So again, our holding costs increase directly. Okay? Our ordering costs, on the other time, if I order 1 unit at a time, my ordering costs are going to be relatively high, right? Because that means every time I need to get an orderage, so it's $10 a pop every time I order a unit. So what I do is I increase my quantity ordered, right? So that I don't have to order so many times, and that relationship is curvilinear, and so it looks something like this, right? And so what we're interested in is we're trying to find when we look for how much should we order, we're trying to find the optimal quantity, okay? That's going to be the lowest total cost of our holding costs plus our carrying costs, okay? And so if I add these two together, right, this curve looks something like this. And the lowest point is at the point where my holding costs and my carrying costs are equal. Okay. And so so what we do is when we're interested in the economic order quantity, or EOQ, or sometimes represented with a Q and an asterisk, right? It's at the point where our ordering costs equal our holding costs. Okay, what was the formula for our ordering costs? So part of that?
D divided by Q times S.
Yep. And so I'm going to set that equal, right, to my holding costs, which are what?
The last one.
Yep, Q divided by 2 times H. So if I solve then for Q to determine my optimal order quantity, basically I'm going to go times S. I was like times 2. Okay. D divided by Q times S is equal to Q divided by 2 times H. Okay. So if I'm solving this, I'm going to go S is equal to Q divided by 2 times H. Invert that to be Q divided by D. Right? Then I go 2ds is equal to Q times Q times H. So then I divide each side by H. And that gets me 2ds divided by H is equal to Q squared, right? So then Q is equal to the square root of 2 times the annual demand times the setup cost divided by the holding cost. I want you to understand that relationship, to make sure that you understand that where we get Q from comes from the fact that we're setting our ordering costs and our holding costs equal to each other. And so as you do your homework, the key for you is going to be to understand what equation you need to use, and then to understand what the variables in the equation mean. Okay? So D represents annual demand. Capital D represents annual demand. Little d usually represents some smaller time period of demand, oftentimes daily demand. Okay? C represents, capital C represents your cost per unit. Q represents your order quantity. S is the cost of placing an order or the cost of setting up to do that order. H is the annual cost of holding or storing 1 unit of inventory. Okay? All right, so they show you, again, they show you that diagram here. Okay? And our optimal point is where the total costs are at their minimum. Okay. Yes?
Is it always going to be, I mean, if you've got the straight line and the curve, can you always just go with the equilibrium at that point? Do you really need the other portion?
Do you need this portion?
Yeah.
No, you're just showing, yeah, I'm just showing you that that's the point. Yeah, so that you can get it because those two cross at that point.
Okay, so you don't even need the third one.
Yeah, so this is just the total cost curve, right? It's just adding those two together. And the thing about the total cost curve, if you notice, and it flies this way, is that when you're at that where ordering costs are equal to setup costs, it's a relatively flat point on that curve. So the fact of the matter is that you're doing some estimation is not a big deal, because we're going to estimate. You can't get your holding costs exactly. You can't get your setup costs exactly, but you're using some estimation. And that's okay, because you're at kind of a flat point on that curve. So if you're off a little bit, you're still better off using economic order quantity to calculate than making some guesstimation. Okay? All right. So the first example that we've got comes from example 11.2 in the textbook. Okay? And it tells us that annual demand, so capital D is equal to 1,000 units. Average daily demand, little d with a bar over the top of it, is 1,000 units divided by 365 days. It's 2.74 units. Our ordering costs are $5 per order. Our holding costs are $1.25 per unit per year. Our lead time is 5 days, and our cost per unit is $12.50. Okay? So given that, I think that we're going to be asked to calculate, the first thing let's calculate is what's our reorder point. Okay? And so, do you remember what we said our formula for reorder point was? It's pretty simple at this point.
Lead time times
Average daily demand.
that one.
Okay. So we're going to go, our lead time is 5 days, right? And our average daily demand is 2.74. So our reorder point then is going to be 13.7 units. Okay? And in the real world, of course, you couldn't order 7/10 of a unit. So, but just pay attention to what Connect asks you to do, whether or not it asks you to round off at a number or with a calculation. Okay? And if we're going to determine what our optimal Q is, we're going to use our economic order quantity formula. So the square root of 2 times annual demand times setup cost divided by holding costs tells us it's 2 times 1,000 times 5 divided by $1.25. Somebody's wrong. It's either $1.25 or $12.50. All right. I'm not sure if that should be $12.50 or not. I'd have to go back and rerun the math.
It says holding costs, so it should be $1.
Oh yeah, I'm sorry. Holding costs is $1.25. The cost per unit is $12.50. There we go. All right. Then when I go to determine my total annual cost, right? We're going to use the formula that says how much does it cost me to buy the units, right? Plus my setup cost plus my ordering costs. Okay. So annual demand times total cost. So annual demand of 1,000 times cost of $12.50 plus annual demand demand of 1,000 divided by my EOQ of 89 times $5, which is my setup cost, plus 89 divided by 2, which is my average inventory, times my holding cost of $1.25 per unit. So my total cost, my total annual cost is $12,611.81. Okay? And so it's when I do these problems, I set them up and do them just like this and figure this term, and figure this term. Because some of the questions that you're going to get are then going to come back and ask you, well, what's the setup cost? What's the annual setup cost? Well, if you set it up like this, you go, okay, well, my setup costs then are, right here, right? This term is my setup cost. Okay, well, what are your annual holding costs? Okay, well, that's this term, okay? So I just work it down the page in that very sequence, okay? All right. So we've been living in the perfect world, but the reality of it is we're not in a perfect world, right? Demand doesn't flow evenly and perfectly like we would like it to. So you have to carry some safety stock to account for the fact that you're going to have variability in both your production and in the demand that you're going to receive, and maybe in some of your vendor lead times. Okay, so safety stock can be determined based on many different criteria. So a common approach, sometimes people just keep a certain number of weeks of supply. Okay, a better approach is to use our probability, our normally distributed bell curve. Okay, so we assume that we know based on historical information our mean and our standard deviation. So to determine the probability, we plot that and note where the amount we have lies on the curve. Okay, all right. So again, this is showing, this is referencing that fact that I have this variation in my demand, okay? And sometimes it's going to work perfectly, and sometimes it's not, right? And I may run out. So what we do is, you'll see this is our basic sawtooth diagram above the blue section. What we do is we add that blue section in terms of the safety stock to say we're going to keep this much extra on hand to accommodate that variability that we have. Okay? So demand is variable but follows a known distribution. After the reorder is placed, demand during lead time may be higher than expected, consuming some or all of our safety stock. Okay? So we adjust our reorder point formula, where it was very simply before average daily demand times lead time. Now we add in for safety stock, we use our Z factor and our standard deviation of lead time. Okay? All right, so let's look at example 11.4. So example 11.4 says daily demand for a certain product is normally distributed with a mean of 60 and standard deviation of 7. Okay? So if I say, when I say daily demand is normally distributed with a mean of 60 and a standard deviation of 7, what is the 60? What
53 to 67 range, somewhere in between there.
Okay? That's true, but that's not where we're headed. Okay? What does the 60 represent? Is it capital D, small d? What is it?
Small d.
Small d. So it's average daily demand is equal to 60. Okay? And then when they say the standard deviation of demand is 7, okay, that's the standard deviation with the small d. Okay? You have to know your formula is the standard deviation of lead time. Okay, so you may have to adjust, right, in terms of if you've got standard deviation of demand, you're going to have to adjust it to meet standard deviation of lead time. The standard deviation of demand means over a one-day time period. Standard deviation of lead time means over the entire set for a lead time. Okay? So that being the case, then the source of supply is reliable and maintains a constant lead time of 6 days. So what does 6 days, what's my variable? What's it?
You need to take R multiplied by 6.
Okay, it's L, right?
Oh, L, sorry.
I'm trying to get you guys to, I'm going to just start at the back of the room. So Ryan, you've got the next one, all right? So the cost of placing the order is $10. So what does the $10 represent in terms of our variables?
S.
Okay. Okay. Holding costs are 50 cents per unit. Adam?
H.
It's 50 cents a unit. Okay. All right. And then there are no stock-up costs, and unfulfilled orders are filled as soon as the order arrives. Assume sales occur over 365 days of the year. Find the order quantity and reorder point to satisfy a 95% probability of not stocking out. Okay. So Matt, if I have 365 days in the year, and I've got average daily demand, how am I going to calculate my annual demand?
To divide 365 by 60?
I'm going to take my 60, so I've got every day I'm going to sell 60, and I have 365 days in my year.
So you multiply it.
I'm going to take 60 times 365 to get my annual demand. So my annual demand then is going to be, I guess they don't calculate that out, but somebody do that for me. 365 times 60.
21,900.
Say it again.
21,900.
21,900. Okay. So sometimes you're given the components, but you're not given the whole. You may have to go look for, okay, how am I going to calculate annual demand? And maybe they're going to say average weekly demand is this, and you're going to assume 50
52.
weeks in a year.
Oh, 50.
Yeah. So you have to watch, because sometimes they'll say 52, sometimes they'll say 50, sometimes they'll talk about days, right? And so it just, you have to pay attention to that level of detail, okay? All right. So that being said, I've got my variables, then it becomes a plug and play, right? I have my EOQ formula says 2 times annual demand times setup costs divided by holding costs. Well, we've got our annual demand, right? We've got our setup costs, and we've got our holding costs, right? So you just plug it into the formula and go from there. So the key is making sure that you can recognize, as you're reading through the problem, how they relate to these variables, okay? All right, so we have our optimal order quantity, okay? And if we want to understand our lead time, right, or excuse me, our standard deviation of lead time, there's a formula that we use for that. I know you're surprised by that. Okay. And it's the square root of the lead time times the standard deviation of demand squared. So in our example, our lead time is 6, right, times 7 squared, right, and we take the square root of that for 17.15. Okay? So our reorder point then, we adjust our formula to be average daily demand times lead time plus our safety stock. So if you're just asked what safety stock are you going to carry, right, you're going to use this information. And if we want a 95% probability of not stocking out, we would go to our table and find out that our z-score associated with that is 1.64.
So you don't use the formula in the Excel file?
You can
for
use the
that.
formula in Excel file.
Okay, when you put the norms inventory, what number do you put in the parentheses?
Let's just do a quick double check of that. I'm thinking there's 2, I believe that norms inventory returns the z-score. So we're going to put norms inventory 0.95.
Okay.
And that's going to give us the 1.65, 1.644, okay?
Okay.
And on the other hand, I think there's other places where you need to know the probability, and you use norms distribution for that.
That's why I was confused on that.
Yep, so to get the z-score, you use the norms IMV, okay? All right. So then we calculate our reorder point as 388 units for that 95% probability, where our z-score was 1.64. So your policy is place a new order for 936 units, because that's the quantity, that's your economic order quantity, every time stock falls to 388 units on hand, and that results in a 95% probability that you won't stock out, right? You have to decide, depending on what industry you're in, if you're saying that, Walmart might run out of toothbrushes, 95% is probably okay, right? If you're saying that an emergency room might run out of a particular product that they need for surgeries, 95% is probably not okay, right? So that's why understanding how those probabilities work is important to those calculations. So, again, we've already talked about our average inventory then. Now that we have variability built in, it's not just Q divided by 2, because that's how much we have on hand, average of what we order, but we have to add in our safety stock to that. Okay? So our average inventory then becomes Q divided by 2 plus whatever safety stock we have. Okay? And if you're asked, well, what's the value of that? What's the Q divided by 2 plus the safety stock times the cost per unit, right? And your inventory turns then become your annual demand divided by the average amount that you're holding on hand, your average inventory, which is Q divided by 2 plus your safety stock. Okay? So just some relationships there. All right. So here's the connect twist. 11.8, which is one of the first problems, and the second problem, 11.14, are basic EOQ problems. They're going to be read the problem, identify the variables, and you're going to be fine. You're just going to plug and play those into that EOQ formula. Okay? 11.17 is the components of the total cost. So they're going to talk about annual ordering costs and annual setup costs. You're going to need to go back to that total cost equation, make sure you understand what components those are. Okay? 11.20 and 11.21 are economic order quantity, calculating standard deviation of lead time, and then determining the reorder points, similar to this last one that we just did. Okay? And so that being said, I thought maybe we would go ahead and open up and do an example. Caitlin, it seems like you've been kind of already started. Do you have one you want me to try to do?
The only thing is the distribution thing that you just showed. I'm not getting the right answer.
Okay, so let's take a look at that one. Which problem number is that?
I guess number 5 or number 2. I think they're usually the same thing. I can get one part, but not the second part.
Okay. So we'll go ahead and open this up. I'll go to the practice homework. And we'll take a look at okay. So item X is a standard item stocked in a company's inventory of component parts. Each year the firm on a random basis uses about 2,000 of item X. Okay, Joe, what is 2,000 of item X? What does that represent?
Every time.
We know that we're probably going to need annual demand, holding cost, setup cost, and potentially see what else we get out of that. So each year, the firm on a random basis uses about 2,000 of item X. Morgan, what do you think?
I'm just pulling it up.
Miranda?
Isn't
What was
that
the
two?
question you asked again?
So what variable? So when we get, as I'm reading through the problem, one of the things I try to do is assign these variables as I read the problem. Okay? So each year the firm on a random basis uses about 2,000 of item X. What does 2,000 of item X represent in the things we've been talking about? Matt?
The demand?
It's the annual demand. Okay? All right. Then as I keep going, Joe, I'm coming back to you. So you
Okay.
All right. Each year the firm on a random basis uses about 2,000 of item X, which costs $25 each. Do you remember our variables? We have the annual demand, we have holding costs, we have setup costs, we have the cost of the item. Sometimes we have the lead time. Sometimes we have average demand.
So you're asking the 25?
Yep.
That would be the cost of the item?
Yep, that's the cost of the item. So Morgan, storage costs, which include insurance and cost of capital, amount to $5 per unit of average inventory.
10 is storage, right? No? That's
So every time, so that's every time, you're looking at the last one where it says every time an order is placed for item X, it costs $10. So we have $5, we have $10 that we need to assign to variables. So $5 represents what?
Oh, storage costs?
Storage costs. So which variable represents storage costs?
H.
H, right? Okay. Miranda, which variable represents setup or ordering costs?
When said, oh, that's S, right?
Yeah. Okay. So you're going to do yourself a favor if you make sure you're familiar with what those variables are before you start doing your homework, or you're going to struggle to try to figure out what goes with what. Okay? Right? And so, so whenever item X is ordered, what should the order size be? Okay? So what equation would I use? What did we work on today in terms of fixed time period? I'm sorry, I'm really blind. Mike?
I'm really blind.
Optimal order quantity?
The optimal order quantity, or EOQ, right? So EOQ is equal to the square root of 2 times the annual demand times the setup cost, 2 times setup, right, divided by the holding costs, right? So now I've got these already set up, and it's just a matter of plugging and playing right back into that equation, right? You can see they've done that here. So they say 2 times the annual demand of 2,000 times the setup cost of $10 per order divided by our holding cost of $5, right? And we take the square root of that. So our optimal Q is 89.44, and it says here round your answer to the nearest whole number. So we round down to 89, okay? Right. Then it says, what's our ordering costs, right? If you remember, we had our total cost equation. D times Q, the total purchasing cost, right? Our ordering costs are represented by,
D divided by Q times S.
inventory carrying costs, represented by Q divided by 2 times H, right? So when it asks you just for the ordering costs, you're figuring this part. When it costs you just for the carrying costs, you're figuring this part. And what you should find, because of what economic order quantity is, those two values should be very close to the same thing. They're going to be slightly different because we rounded down, but they're going to be pretty darn close to each other. And if you're working a problem on an exam and you're doing economic order quantity and then you're doing total cost and they're not close to the same, you've done something wrong, okay? Because economic order quantity should always bring us back to a point where these two are relatively close to equal.
What would Q be?
Okay, so Q is what we calculated here, right? Our economic order
That's the
quantity.
EOQ.
So, yep, so we calculated 89 for our EOQ. Okay? Does that help you, Caitlin?
That one I got right because we didn't have to find the Z value.
Okay. So is it this one that you struggled with?
Yeah, it's just part B I couldn't get.
Okay, so make sure that you're fixing. Did you do the standard deviation of lead time rather than standard deviation of demand?
Yes.
Okay, and so in this case, it starts out. Let's just go through this. Let's do. I know Caitlin, you're probably already there, but let's go ahead. So again, you kind of have these listed variables that we use, right? All right, let's go ahead. Tires. Okay. Gentle Ben's Bar and Restaurant uses 5,000 quart bottles of an imported wine each year. What does that represent?
That represents the annual demand.
Annual demand. We've got 5,000 bottles of wine. The effervescent wine costs $3 per bottle. Aaron, what does that represent?
Is that C?
Yep, because that's our cost per unit, right? Okay. And then, and it's served only in whole bottles because it loses its bubbles quickly. Ben figures that it costs $10 each time an order is placed. Kirsten, what does the $10 represent?
S.
Yep. Every time I place an order, or my setup costs. Okay. And holding costs are 20% of the purchase price. Okay. So, Caitlin, that's one that's a little bit different. So, how do we? Our holding costs are 20% of our purchase price, which is, we said, was $3. Right, so you have to calculate your holding cost of 20% times 3.
Okay.
because they're not giving us the holding costs directly, okay? So just recognize sometimes they give us holding costs and they say it's X amount, and sometimes they say it's a percentage of your cost, okay? All right. It takes 3 weeks for an order to arrive, so your lead time is 3 weeks, right? Weekly demand, so average weekly, and I'll just put weekly here, right, is 100 bottles. Okay? So now I'm going to come over here and I'm going to plug in 2 times 5,000 times my setup cost of 10 divided by my holding costs, which are going to be 3 times 20%. Right? If life is good and we do the math, that should come out to 408.25. Or we round off to 480 bottles. Okay? And then part B says, at what inventory level should he place an order? Well, we know that our reorder point is average D times lead time plus Z times the standard deviation of lead time. Right? We were given, then we would like to use an inventory system that minimizes inventory costs and will provide a 95% service probability. So we need a Z-score for 95%, right? We know that our average weekly demand is 100. We know that our lead time is 3. If we look up with that norms inventory, we're going to get 1.64. Okay, now I have to adjust. I'm given, somewhere in here I'm given standard deviation of demand, right?
Is it 30 bottles? Is it the first
Yeah,
paragraph?
so weekly demand is 100 units with a standard deviation of 30 bottles. So my standard deviation of demand is 30. So if you remember, our formula for the standard deviation of lead time was the square root of lead time times the standard deviation of demand squared, right? So if we're doing this right, it should be the square root of lead time of 3 times 30 squared, okay? So 30 squared is what? So do that on your calculator for me. 900 times 3 is 2,700, right? And the square root of that is
51.96.
51.96. Okay? And so
You're just rounding.
it's going to be 300, and then what's 1.64 times 51.96?
97.7.
Say it again.
97.7? Did you say times?
1.64 times 51.96? 85.2? Double check that math, is that right? 1.64 times?
I just times put it in wrong.
You put it in wrong? Okay.
Yeah.
All right. So then that brings us back to 385.2, and we round it off to 385. Okay? So the things where you can make a mistake, that's easy to make a mistake, make sure that you square your standard deviation of demand first, and then multiply it times the lead time, and then take the square root. Make sure that you're doing that in Excel or on your calculator, make sure you're doing it in that right order of events. Okay? Other than that, I think smooth sailing. Have 100 cups, right?
It's gross.
Dude, I really don't think, I don't think
I said I just have a
Yeah, right.
I worked with, and that I can say that every day. That might go out.
Have you ever had that, right?
Wait, are we allowed to kick? We're allowed to kick on us.
That's not
how that works.
And if you think about it, tell Matt congratulations. Matt's a new dad as of yesterday. Congratulations.
Oh, okay. All right, I was like, whoa. All right, congratulations, man.
My grandparents. So he's like, I can just drop you off at home.
yeah, you don't have class.
And what? Yes, I have one now, and I have one last. I have 2 this summer. Is it about that? No, she should. Because one of my classes is only offered. This is 13. That was the only option. Well, that's where mine was in Professor Allen was
It's not here.
And these classes that I marked out are the classes that aren't offered in the spring, which means that you either have to take. So my z-value in mine is 1.642, but it's saying mine's wrong when I have the other numbers in the formula.
Okay, so let me stop the recording.